Welcome to Unit 2, Classification Systems. Let's talk about our definitions here at first. Taxonomy, systematics, classification, and categorization. For our purposes here, we will consider these words synonymous. Classification is the science of grouping objects, ideas, or data on the basis of shared characteristics. The goal in root cause analysis is to drill down to identify latent root causes that contributed to a mishap. That if corrected, those latent root causes, if corrected, would prevent or mitigate same or similar mishaps from occurring in the future. So as we identify those latent roots, the human roots, the physical roots, we have a lot of data. The goal then is to develop classification systems where root causal factors can be grouped together, and those causal factors within the group share like characteristics, and those in other groups are different. When we group like items, we better organize the data, and we learn areas of focus for safety, for accidents, profits, or losses. We learn what areas are causing problems, and we learn where our mitigation strategies must target. In aviation, if you can believe this, the National Transportation Safety Board investigates over 1,500 aviation accidents every year, and those aviation accidents contribute to, or they're responsible for, approximately 400 deaths annually in the United States alone. As investigators recreate and identify events leading up to the accident, they seek out and identify those root causes. Classification of those causal factors, grouping similar causal factors together, helps us focus intervention strategies on common safety issues. In order to prove the effectiveness, the absolute effectiveness of classification systems, I would like for us to take a look at the aviation safety record since its inception. Aviation accident investigations and databases are set up to identify technical aspects of what went wrong. Why do you think that is? Well, I would suggest to you that the technical aspects are easier to classify than the human. The human is harder to classify, and as a result, accidents due to technology have decreased drastically because we know what to focus on. What's left over is an astounding 80% of all accidents are primarily caused by human error. And in all reality, the rest have human factors contributing to the cause. Let me illustrate that with this very generic chart. It represents that philosophy that in the early years of aviation, technological factors contributing to an accident were much higher, human causes were much lower. But as accidents occurred and as investigation occurred, technological systems were classified, finding areas needing the most attention, such as metallurgy, redundancy, systems, etc., and those areas needing the most attention were fixed. As a result, technology has become less and less to blame as the years have gone on, and the human, as the principal factor contributing to accidents, has become more and more the culprit. Wigman and Chappell address that in your reading assignments in their comparison between the engineering process and the human error process of the accident investigation loop. Let's take a look at both of these, starting with the engineering process loop. Let's look at that one first. Accidents are investigated with highly sophisticated techniques and procedures. Accident investigation in technology is very well defined. The root causes are found, they're discovered, and they're stored in a well-defined and causally related database that facilitates data analysis. That database facilitates data analysis so we can quantitatively identify common mechanical and engineering safety issues. That yields data-driven research. Data-driven research provides effective and targeted intervention programs. That means we know what to focus on to enhance safety in these areas. Those targeted intervention prevention programs can help reduce the accident rate. For technology, this has been highly effective. Now contrast that with the human factor process loop. We are getting better with accident investigation techniques targeting human error, but really, what is easier to identify? Technology, a bolt cracked due to fatigue, or human factors, a pilot miscommunicated an important message due to fatigue? It is tough to identify human root causes, but it is imperative. But now we get into a bigger issue. Even if we did identify human causes during accident investigations, the databases are not set up to handle those root causes. That makes data analysis very difficult, if not impossible. So we've talked about our investigation techniques, a little bit less advanced in the human aspect of it. Our accident databases, they're not really set up for human root causes, makes database analysis a little more difficult, or a lot more difficult for that matter, which leads to fad-driven research. What does that mean? Well, when we cannot analyze data to derive areas of common problems, we start relying on gut feel, on intuition and fads to determine what intervention strategies we need to implement. Those intervention strategies are designed to be implemented to enhance safety and reduce accidents, but it's been a very ineffective method because we rely on gut feel rather than data. The purpose of investigation is not to place blame, but to learn from root causes, implement effective, targeted mitigation strategies to enhance safety and to prevent the reoccurrence of accidents. We use this comparison to illustrate the sheer impact a good classification can have to enhance safety. In the next video, we will talk about what qualities we look for in a good classification system and perhaps how even to design our own.